Here we will take some example on the Cauchy-Euler type equation. So example 1 is solve x square d square y by dx square plus x, sorry, minus x dy by dx plus y equal to 0. Now, in order to solve this, what is the transformation we will apply? We will take, let x equal to e to the power z. So, if x equal to e to the power z, z will be nothing but log of x. Okay, so because of this transformation, we can have xd will be d dash and x square d square will be d dash into d dash minus 1. So wherever xd is there, we will put d dash. Wherever x square d square is there, we'll put d dash into d dash minus 1. And so if we put there in the given differential equation, it will be d dash into d dash minus 1 minus d dash plus 1 of y equal to 0. That means d dash square minus d dash plus 1 of y equal to 0. Further, you can simplify this and you can write it as d dash square minus 2d dash plus 1 of y equal to 0. So here you can see that it is the differential equation which does not contains any variable as a coefficient. So, but here you remember that this differential equation is in terms of z. So we started with the differential equation which is the differentiation with respect to x. We denoted it d, and then we converted it to the differential equation in terms of d dash, which is nothing but the differentiation with respect to z. So now it is a constant coefficient differential equation. Since right hand side is 0, we can say it is homogeneous differential equation with constant coefficient. And the solution of this differential equation is only complementary function. No need to find the particular integral. So how can we get complementary function? To write the complementary function, we will take d dash equal to m, and we will write the auxiliary equation m square minus 2m plus 1 equal to 0, and that means m minus 1 whole square equal to 0. So m equal to 0 comma 0, repeating two times. So m minus 1 equal to 0, so m equal to 1 comma 1, m equal to 1 comma 1, so it is repeating two times. So the complementary function will be c1 C to Z. Since it is repeating two times, remember that here we will write in terms of Z because we are solving the differential equation which is in terms of D dash. So this one and e to the power 0 into Z. E to the power 0 into Z is 0, and so we can have C1 plus C2 log x. So this is the solution. After getting the solution in terms of z, please replace the value of z as log x, and that will be the final solution. Next, we will take another example. Solve x square d square minus 2xd minus 4 of y equal to x square plus 1 by x. So now, since it is a Cauchy-Euler type equation, so we will apply the transformation, let x equal to e to the power z, and that implies z equal to log x. Because of this transformation, we can take xd equal to d dash and x square d square equal to d dash into d dash minus 1, where d is nothing but derivative with respect to x and d dash is nothing but derivative with respect to z. So after substituting these things in the given equation, we can have what we have? We have d dash into d dash minus 1 minus 2d dash minus 4 of y equal to, you see, x equal to nothing but e to the power z. So x square will be e to the power z whole square. E to the power z whole square is equal to e to the power 2z. So in place of x square we will write, so whenever x is replaced by z, in the original equation wherever x is replaced by z, we will write e to the power z, and then 1 by x will be nothing but 1 by e to the power z, that is equivalent to e to the power minus z plus e to the power minus z. So now you simplify this and try to write the simple form: d dash square minus d dash minus 2d dash minus 4 of y is equal to e to the power 2z plus e to the power minus z. So this is equal to d dash square minus 3d dash plus 4 of y equal to e to the power 2z plus e to the power minus z. Now you see that this is the constant differential, this is the differential equation with constant coefficient. So we can able to write the auxiliary equation m square minus 3m minus 4 minus 4 equal to 0, and that is equal to m square minus 4m plus m minus 4 equal to 0. That means m minus 4 into m plus 1 equal to 0. M equal to minus 1 and 4. So accordingly, these roots are real and distinct. So the complementary function will be c1 e to the power minus z plus c2 e to the power 4z. Remember, our differential equation, constant coefficient differential equation is in terms of z. So the solution first will be in terms of z. And in order to get the final solution, that z will be replaced by log x. So that means c1 e to the power minus log of x plus c2 e to the power 4 log of x. And you can get it c1 x to the power minus 1 plus c2 x to the power 4. So in case of variable coefficient, we can write the complementary function in this way. If m1, m2, m3 are the real and distinct root, then the if m1 m2 m1 is not equal to m2 is not equal to m3 are the real and distinct root, then the complementary function will be c1 x to the power m1 plus c2 x to the power m2 plus c3 x to the power m3. We can write in this way. So m1 m2 are minus 1 and 4, so we can write this. So you can write in this way, or directly you can write c1 x to the power m1 plus c2 x to the power m2 plus c3 x to the power m3. So like that you can write. Now we will go for pi. Since it is a non-homogeneous differential equation, pi will be 1 by d dash square minus 3d dash minus 4 e to the power 2z plus e to the power minus z. So here we are having two functions, so we can have two pi. One pi will be d dash square minus 3d dash minus 4 e to the power 2z, and another pi will be 1 by d dash square minus 3d dash minus 4 e to the power minus z. Now wherever d dash is there, you put here 2, and wherever d dash is here you put minus 1 here. So that means 1 by, we can have 1 by 2 square minus 3 into 2 minus 4 e to the power 2z plus 1 by, here we will put d dash equal to minus 1, minus 1 square minus 3 into minus 1 minus 4 e to the power minus z. Okay, so this one will be nothing but minus 10 plus 4 is minus 6, 1 by 6 e to the power 2z, and this one will be plus 1 by 0 e to the power minus z. So if denominator is 0, don't stop there. You proceed further another step. Minus 1 by 6 e to the power 2z will be as it is. Here what you do, you multiply the numerator by z and differentiate the denominator by d dash. So 2d dash minus 3 e to the power minus z, and so you will get minus 1 by 6 e to the power 2z, and this one will be minus 2 minus 3 minus 5, so z by 5 e to the power minus z. Again e to the power 2z is x square, and so we can have minus 1 by 6 x square, and e to the power minus z is x to the power minus 1, and z equal to log x, so log x by 5 into 1 by x. So this is your pi. Once after getting pi, you write the complete solution as complementary function plus particular integral. So this is the procedure to solve the Cauchy-Euler type equation.